The Hubble Space Telescope is currently in safe mode. It's paused science operations and it's waiting for instructions from Earth. Let's talk about what's wrong, the ongoing problem with the observatory's gyroscopes, and what the future of the Hubble Space Telescope holds. On April 23rd, the Hubble Space Telescope automatically entered safe mode when one of its 3 remaining gyroscopes gave off faulty readings. Hubble uses its gyroscopes to point the telescope at objects. They also hold Hubble steady. Remember, it's orbiting the Earth at 17,500 miles per hour or 27,300 kilometers per hour. Gyroscopes are why Hubble is able to point precisely at certain points in the sky for long periods of time. They measure how fast it's moving from one object to another. These gyroscopes are crucial to the observatory being able to observe. But how does Hubble actually point at things? It has a complicated pointing system composed of reaction wheels, fine guidance sensors, star trackers, and gyroscopes. Here's a basic rundown on how it works. There are 5 types of sensors that make up the pointing control system: the gyroscopes, the fine guidance system, the coarse sun sensors, the magnetic sensing system, and the fixed head star trackers. The coarse sun sensors are how Hubble figures out where it is relative to the sun. The telescope always needs to be pointing at least 50 degrees away from the sun to protect its instruments. Sunlight could degrade the black paint that lines the optical tube, and also heat could cause expansion within the telescope that could damage it or affect its observations. The magnetic sensing system is essentially Hubble's compass that uses the Earth's magnetic field to orient the telescope. The gyroscopes measure Hubble's direction and rate of movement when it's turning. Hubble originally had 6 functioning gyroscopes. 3 were operational, while the other 3 were considered spares. 3 of these gyroscopes work in tandem to measure the telescope's movement in all 3 directions. Finally, the fixed head star tracker is comprised of 3 fine guidance sensors. These use starlight coming into the telescope's mirrors to lock onto the stars to ensure the attitude of the telescope does not change. This allows Hubble to remain steady and fixed precisely on a target during long exposures. For example, Hubble's extreme deep field image was the culmination of 50 days of total exposure time collected over 10 years. So then, what's happening with the gyroscopes and what are these faulty measurements they're sending back? Well, Hubble's gyroscopes are among the most stable and accurate ever built, but as you can imagine, they are also delicate. The gyroscopes are specifically vulnerable to wear and tear on thin metal wires called flex leads. These are used for power flow in and out of the gyroscopes. They are about the width of a human hair. Due to degradation, these can cause the gyroscopes to start sending back faulty readings, which is what's happening right now. The flex lead degradation is causing incorrect rate measurements called biases. Eventually, the gyroscopes will fail. Over the course of the Hubble Space Telescope's lifetime, it's lost 33 gyros due to corrosion on the flex leads. The 3 non-functional gyros on Hubble currently have this issue. Scientists have known about this problem for years, and they have developed tools to increase the lifespan of the gyroscopes, such as software correction for the biases, as well as improvements in manufacturing that have led to these gyroscopes being more durable. And if you're wondering, why doesn't NASA just use more durable gyroscopes? Remember, they have to balance durability with accuracy. Durable gyroscopes make no difference if they aren't accurate enough. And also, the telescope launched on April 24th, 1990. We just passed the 34th anniversary of Hubble's launch. It is aging. It's amazing that it has been operational for this long, but it was never designed for that. The reason we've managed to keep Hubble operational for this long is because there have been 5 different servicing missions to the telescope with the Space Shuttle. The last one was in 2009. Astronauts on STS-125 replaced every single one of the 6 gyroscopes during that final mission. They're replaced in pairs. Of these 6, only 3 are functional these 15 years later. The telescope is currently not conducting science operations. It is waiting patiently in safe mode while the ground team figures out what to do. We've had issues with this particular gyroscope before. Faulty readings on November 19th caused the telescope to enter safe mode just like now. but the telescope is back to doing science by December 8th. Scientists are hopeful that the pause in operations will be brief once again. Back in 2018, they managed to fix the gyroscope simply by turning the power off and turning it back on again. But what happens if they can't get that necessary third gyro operational again? Well, that doesn't mean that the Space Telescope would be shut down, but we'd move into the final phase of operations for the Hubble Space Telescope. Back in 1999, when scientists realized that the gyroscopes would likely be the limiting factor on Hubble's length of service, they devised a plan for the Hubble telescope to operate on just one gyro. It can also operate on two gyros, and did for a while to prolong its life after the Space Shuttle Columbia disaster in 2003, when it was unclear whether there would be any more servicing missions. The difference between two gyro mode and one is pretty negligible, so scientists prefer one gyro mode because it keeps one gyro in reserve. One gyro mode basically substitutes the other sensors that I talked about previously for the other two gyroscopes. It would go in steps. Step 1, the magnetometers, sun sensors, and single gyro would work to point Hubble within 10 degrees of the target. Step 2, when the observatory is within 10 degrees of the target, the fixed head star trackers would take over and work with the gyro to get the observatory within a few arc seconds of the target. 1 arc second is 1/3600th of a degree. Step 3. At this point, the fine guidance sensors would step in to find a guide star and move the telescope within 150 milliarc seconds of the target. 1 milliarc second is 1/36 millionth of a degree. Step 4. The sensors continue working together to refine Hubble's pointing until it's within 20 milliarc seconds of the target. Once it's pointed at the target, the single gyroscope can maintain Hubble's position basically almost as well as 3 working together. The difficulty is in getting it there. In this mode, Hubble will lose 20 to 25% of its productivity because of the time involved in pointing, which means significantly less observation time. Additionally, it slightly limits what science Hubble can do. It would not be able to look at anything closer than Mars in one gyro mode. I also want to note that NASA and SpaceX embarked on a feasibility study in 2022 for the possibility of servicing the Hubble Space Telescope and boosting its orbit with a private Crew Dragon mission. This would be the Polaris program funded by Jared Isaacman, the first of which is scheduled to launch this summer. That would be Polaris Dawn. But there are 3 total missions scheduled, and if I had to guess, I don't think they would do a boost or servicing mission for Hubble before the second mission. It's worth noting that this is something that the billionaire Jared Isaacman is very passionate about personally, and he would be willing to do this at little or no cost to NASA, which is pretty a big deal, and makes it more likely that this is going to happen. And I honestly think personally that this would go a long way towards making private spaceflight more interesting for the general public, who currently most people think is just a place for billionaires to play. We're still waiting to hear whether this mission will happen, but according to NASA's latest budget documents, this reboost is still a possibility. It could extend the lifetime of the Hubble Space Telescope by 15 to 20 years. And that is just about all I have to tell you about the current situation with Hubble. Let's hope that I have good news to report about it soon. Thanks for watching. I'm Swapna Krishna, and this is Ad Astra.